Let's talk about factoring a perfect square trinomial. What are perfect square trinomials? Well, we first start with a trinomial of this pattern. A squared minus 2 times A times B plus B squared is equal to the factor A minus B times another factor A minus B. So that's why we write A minus B as one factor and then write it to the exponent of 2. What's another perfect square trinomial? Another pattern would be A squared plus 2 times A times B plus B squared is equal to the factor A plus B squared. Alright, so there's obviously some patterns. So we're going to do A, B, and C first, or in this first column. There's a pattern there. In fact, it follows this red pattern here. So off to the side, if you really wanted to, you could write A is equal to X. And then for part A there, A is equal to X, and B is going to equal what? B is equal to 9, right? Okay. You don't have to do this, but you realize this is going to be A squared minus 2 times A times B plus B squared. So if A is X, so then you get X squared minus 2 times what? Well, A is X, so you put X, and then times B, which is 9, and then plus what? 9 squared. And so notice, we really do have that expression in part A. So this is what we call a perfect square trinomial. Now, if it follows that pattern, we simply could write the patterns of A minus B quantities squared. So if you already know what your A is, well, you already know what A is actually X. And then you write a subtraction sign, and then you write your B, so it'll be 9 squared. And just like that, you have factored it. Okay? If you're not confident, you could always check by multiplying. What do we mean by check? You could always go back to the trial and check method. So x minus 9 quantities squared is actually equal to x minus 9 times x minus 9, which equals x squared minus 9x plus 81. And this checks. Okay, that is our original product. Another way to check is, perhaps you know how to multiply a perfect square trinomial already. So this is another way to check. If you did x minus 9 quantities squared, there is a pattern to multiplying this. That is, you take your A, which is x, and you write x squared. Then what you do in your head is you do x times negative 9 and then double it. So I put the 2 at the end. So I go x times negative 9, then double it, and that will be your middle term. So minus 18x. And then finally, square your 9. If you square your 9, you get 81. And so yes, this checks. That's pretty cool. So a couple different ways to check, but you always check by multiplying. Let's start over. Let's do part B. So in part B, off to the side here, part B here, once again A is X, and this time B is what? B is 1. So if you're able to identify that pattern, that is awesome. You do want to check though. So I'm going to perform a check after I factor this completely. So this becomes parentheses, x minus 1 quantity squared. Let's make sure we check, and we can do that quickly. X minus 1 quantity squared. We square the x. Multiply what? Remember the pattern is what? Multiply x times negative 1 and then double it. So that means negative 2x is the middle term, and then finally square the 1. But what's 1 squared? 1 squared is just 1, and so yes, it checks. So whenever you're factoring trinomials, you never complete the procedure until you actually check. So don't forget to check. Check, 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 and we check by multiplying. Let's try again. Practice, practice, practice. We keep trying, practice, practice, practice. Trying. Okay, so we're at part C now. Part C. What is your A in part C? A is R. And what is our B? B is 3. So I am really applying a trial and check method to factoring a perfect square trinomial. If that's the case, we're going to write equals R, parentheses R, minus 3 quantity squared. Let's check. R minus 3 quantity squared, square the R. R times negative 3 is negative 3R, double it, so we get negative 6R. And then square root of 3, we get plus 9. It checks. That is so awesome. So once it checks, go ahead and circle your answers. That's an expression that's correct. That's an expression that's correct. And that's an expression that's correct. Let's try the other pattern. The other pattern is a trinomial where the first term is a perfect square and the last term is a perfect square. But the middle term has a plus sign. So in the previous 3 examples, the first term is a perfect square, the last term is a perfect square, and there was a minus sign. So those are ways to distinguish the patterns. Let's say this again. So in this second column for D, E, and F, the first term is a perfect square, and the last term is a perfect square. So the hint to you guys is, know your perfect squares from your multiplication facts. That would also help you identify these patterns and be able to distinguish these things quickly. So why don't we try part D. Part D, A is X, and B is 8. Once again, we're going to do a trial and check method. We're going to go parentheses, X plus 8, and then raise it to the second power. Let's check. We check by squaring the first term. Then we do what? We do X times 8, then double it. So that means plus 16X and plus 64. So that is the shortcut of multiplying X plus 8 quantity squared. Okay. What was the other way of checking? You can also just check by writing things out in more detail. So you could write X plus 8 quantity squared is equal to X plus 8 times X plus 8. And then you could use the FOIL method if you want. But you're losing the benefit of recognizing patterns or practicing in such a way that you remember a pattern. Okay, this of course is a lot more writing and a lot more work. And you are losing a little bit of time there. But if you're writing fast, you can make up that time. So that's another way to check. You could just simply do it that way. It checks. So if it checks, then you could circle your 2 factors. Your factor is X plus 8, and your other factor is also X plus 8. All right. Why don't we try something else? Why don't we try part E? Why don't we just write W plus 7 quantity squared and then just check it. W plus 7 quantity squared is equal to the first term squared plus W times 7, which is 7W. Now double that, so plus 14W. Plus 7 squared, which is 49. That does check. Ta-da! So if it checks, go back and circle your 2 factors. You see that these are really, really special patterns. Part F. What do you think in part F? Well, A is equal to U. A is equal to U. And B is equal to 6. So let's try U plus 6 and then quantity squared and then just check it. u plus 6 quantity squared is equal to u squared plus 6u, or u times 6, which is 6u, and then double it, you get 12u, and then plus 36. It does check. Ta-da!